science and information technology, and the implementation of the e-governance project to the remotest part of the country and the remotest part of the globe. So definitely the domain of the application will be enhanced, and as much as the domain will be enhanced, and there will be a greater degree of the challenges to the security and privacy will be there. As for example, if there are 5 users, there is less security challenges. If there are 5 billions of users, the security challenges are more. So what I foresee, the emerging area is now the security, whatever you tell, whether it is cyber security or web security, or as a whole you tell IT security, that will be one of the very important area in the future days where a lot of manpower will be required. The second area, what I visualize, since we are passing through the different number of latest technologies and very high-speed computing facilities, one day we are having the simple networking concept, we are talking of the high-speed networking concept, we are having the different time of the emerging computing concept, whether you tell it is the cloud computing, nano computing, the quantum computing, the molecular computing, biocomputing, and smart computing, whatever you tell, green computing, and the social computing, all these things, along with the integrity with the different platforms of the intelligence. And initially we are talking of the artificial intelligence, which can be considered the base of the other intelligence, from AI to BI, business intelligence, from BI to CI, computational intelligence, from CI to DI, data intelligence, from DI to EI. Today we are having the emotional intelligence, whatever tell. This is a time where the time we will have to make the integration of the technology. And Dr. Dharm Singh will be delivering a topic on the smart computing and IoT. And in the IoT is also the integration of 4-5 computing, 4-5 technologies. This is a time for the integration of the technology. That is why a emerging area is that. So application program interfacing area where we will be requiring the huge amount of manpower to be consumed in the future days. The third area, what I am visualizing, that is one of the emerging area, and that is the integration of ICT in the wearable technology, that will be the complete application of the embedded technology, and what the wearable commodity will be wearing, whether it is shirt with the dress, with the smart dress, cloth with the smart cloth, watch with the smart watch, and goggles with the smart goggles, shoe with the smart shoe, and every commodities will having the communication capability. And this the thing is that we need a lot of professionals, lot of technocrats who will be working with embedding the things with these wearable commodities, that is the wearable technology. The third area. The fourth area, what I am visualizing, that everybody know, one is that Industry 4.0, another is the Education 4.0. What this pandemic situation compelled us to go for the Education 4.0, not only in India but the whole globe. That you might assume the world is having 7.7 billion of the population, and 4.3 billion of the people there directly or indirectly was connected with the teaching and learning process, and you will be happy to know that 70% of the learners have got the online platform during the pandemic period, constituting of 170 countries. And this will lead a lot of development to be done, because that was not sufficient. As the Harvard Business Survey tells that the 70% of the learners who are not satisfied with the broadband connectivity, with the conducive environment and all these things. We will have to flourish a lot of things, a lot of techniques and a lot of technology in this area in the Education 4.0. And the Industry 4.0, obviously the integration of the robotics, IoT and IoT in the industry, there will be smart industries, smart devices, and smart machines and all these things. And today they tell that the billions of the devices have been connected under the IoT, that is 26 billion of the devices to be connected by the end of the 2020, and 50 billion of the devices have been connected with the internet. That you see the tremendous area where you will be needing a huge manpower. This Industry 4.0 is one of the most emerging area where we will be doing. This is the fifth area, as I told. And the sixth area, as usual, as there is a quantum growth in the volume of information and data in the business organization due to the top business competition. And day to day, whether it is the business sector, industry sector, or service sector, and that is why if they are given back to the big data, you see the level of data as it is increasing In 60, we dealt with the isolated data, 17, the file management, 18, the database management, 19, the relational database management, 2000 in data mining, 2005 data warehousing, 2010 big data, and the data science concept we are having. So definitely, this is one of the most important area because the content growth of the data and information will continuing day to day, and it will larger and larger. That we will be getting a lot of professionals in the big data analysis field, in the business intelligence. So that is the huge number. That is the big and emerging area, the big data analytics and the business intelligence. Obviously, which will be bringing together all the things like business intelligence and this machine learning and all these things that will definitely. So these are the emerging area. I do think today our three speakers will be also discussing very prominent areas. Dr. Dharm Singh will be discussing on the smart computing and IoT, and Madam Preeta Saranji will be also discussing very interesting optical biosensor. That's very burning area and very emerging area of this thing. And Madam Aruna ma'am will also be talking of the artificial intelligence and machine learning. I do think all the participants will be highly benefited from the delivery to all the organizers and the engineering college particularly, and the management of this great college, and particularly our state student coordinator Monica ma'am for organizing this international webinar on such a effective topic and such a topic of the demand of the contemporary era. I must have to congratulate each of you. And with this, I want to conclude my speech by expressing my gratitude and millions of thanks to the organizer of this international webinar, and namaskar and jai Hind. Thank you very much.
Thank you so much, sir. Thank you, sir, for your wise words and sharing your vast knowledge with us. We are really blessed to have you with us in this event. Thank you very much. Now we will move ahead and we can start with the keynote address. For this, I would like to invite Professor Dharm Singh Jat, Professor Namibia University of Science and Technology, for keynote address. But before that, I would like to give brief introduction about Professor Dharm Singh Jat. Professor Dharm Singh Jat has received his Master of Engineering and PhD in Computer Science and Engineering from prestigious universities in India. He is Professor of Computer Science at Namibia University of Science and Technology from 1990 to 2014. He was with College of Technology and Engineering, Maharana Pratap University of Agricultural and Technology, Udaipur. He has guided about 8 PhDs and 24 master research scholars. He is the author of more than 146 peer-reviewed articles and author or editor of more than 16 books. His interest spans the areas of multimedia communication, wireless technologies, mobile communication systems, etc. He has been recipient of more than 19 prestigious awards such as Eminent Scientist Award, Distinguished Academic Achievement, Eminent Engineering Personality, Award of Veteran, CSI Significant Contribution, Best Faculty Researcher, etc. Professor Dharm Singh Jat is a Fellow of Institution of Engineers, CSI, and a Chartered Engineer. Now, I would like Professor Dharm Singh Jat to address the participants with the topic. Sir, please.
Thank you. Am I audible now?
Yes,
Yes,
yes.
sir. Yes, sir. Yes.
Okay. Thank you very much. Today's chief guest, Professor A.K. Nayak, Mr. R.K. Vyas, a fellow member of Computer Society, Dr. Misra, Dr. Monica, and the other speakers, Dr. Sharan and Dr. Aruna, dear students, guests, and the participants. First of all, I would like to thank Professor A.K. Nayak who inviting me this prestigious occasion and for this prestigious institution. So I visited today in the morning.
We are thankful to you because you are honoring us by your participation. Thank you.
No, you know, I want to say that, okay, Professor Nayak, he never told me that he is inviting me. He said, I need to give my lecture somewhere in the event. So I cannot say no anytime if I'm not busy somewhere else. So thank you, Prof. Nayak, again. And I also would like to thank the Sankaracharya Engineering College, Bhilai, because I visited, I think, 88 in Bhilai. Somewhere there is a steel plant in Bhilai, I suppose. Yeah. So thank you again, Monica, for inviting me and your department and organizing committee for this prestigious occasion. And can I share now my presentation now? Can I? Monica, I think I have a right for presentation.
Sir,
Can you make me as a
sir, you can start your PPT, sir. It's visible now. Your presentation is visible now. So you just click on open your PPT, please.
no? But I cannot go inside. I think there is an arrow.
No. Uh,
I think you need to make me as a presenter.
you close this, sir.
Okay.
You close this. Yeah, it's
You
working
can
now,
see
sir.
my screen. You can see my
Yes, sir.
screen now.
Yes, sir. Fantastic, sir.
Okay. Good.
Yeah.
Say again. Yeah. So
Yes.
today I'm going to present about the smart computing communication enabling future Internet of Things in this prestigious occasion on international seminar on emerging areas and in computer science. Before the technical discussion, I want to share some important things about our university because I am working here since 2014 as a professor in computer science. So the Namibia Institute of Science and Technology is a vibrant institute of higher learning with approximately 11,000 students enrolled, of which about 650 are international students representing 32 countries and 4 continents, including Indian students also in PhD program. And I want to share important news that last week we received a UNESCO Chair Award, and I am the chair of UNESCO Chair in Smart and Secure Environment. And in this particular UNESCO Chair, we will deal smart communication, big data, as well as the cyber security. So if someone is interested to collaborate and some institution is interested to collaborate with us in the research areas, then we are also welcome. Yeah, Namibia is the famous regarding the tourist. It's a tourist place. It's a good place, and it's a safe country. And you see here is I don't know. You can see my mouse and pointer here. This one is somewhere is the sand. Can you see the pointer? Someone?
Yes, sir.
Hello. Okay. Here, this one is the sand dune desert, and here is the sea. So in Namibia, Sandwich Harbor is one of the biggest sand field in the world. And in this case, the sand dune is 100-meter run straight in the ocean. You can see, and there is some also the stream of sands here, and also streaming coming from this sea. And this one is, I think, I think this is the one of the beauty in Namibia, especially where we can see the desert as the sand or desert. Regarding some of the Indian movies, is also shoot here. Here is the Ghazni in Africa. This is the place is called as Social Valley. So Bollywood blockbuster film Ghazni was shot in 2008 sometime. So this I want to share why, because you see at the invitation of His Excellency Dr. H. Gengos, the President of Republic of Namibia, His Excellency late Sri Pranab Mukherjee, the President of Republic of India, paid a state visit in Namibia during 2016. And he visited our institute and he gave some lecture. I'm here somewhere. I'm sitting here. This and here is my dean is sitting here. So the delegation of the President of India includes the Honorable Minister, Honorable Minister Jitendra Singh, Minister of State, Prime Minister Office Honorable at that time, and Surendra Singh. I think he's MLA, and Sri Mankus Lakshman or something. He is also MLA. I don't know. I don't know which constituency he has. And our faculty of Computing and Informatics. So the President of India, His Excellency late Pranab Mukherjee, pledged Indian support for Namibia skill development when he made the announcement during the address to a Namibian academic community as the part of 3 days state visit. Here is President Pranab Mukherjee also addressed the Indian community at the reception organized by his honor by the High Commission of India. You can see she is my wife. I am somewhere here. She is my daughter. Now she is doing master in electrical computer engineering from University of Southern California. Yes, my son is studying here. I already told you that we have established a center of excellence IT in collaboration with the government of India and government of Namibia, and we are running some type of advanced courses as well as some research activities in this one. I'm also the IEEE distinguished speaker, so that's why I want to show this slide. If you are interested, then you can also think about this one. I'm also the ACM speaker, so sometimes I visited many countries and under the umbrella of ACM as well as IEEE DSP scheme. Now I'm coming to for the technical part. Is there any time limit for me, Monica? Can you tell me the time, total time?
No, sir, no. You can continue.
Please continue.
Okay. So I would like to highlight the importance of smart computing, communications, enabling future Internet of Things devices. Nowadays, we are in the, as Professor Ek and I already told you that nowadays we are fourth industrial revolution where most of communication devices in the physical world in all application areas are becoming more capable and more connected. So the digital revolution is powered by the Internet of Things, big data analytics, smart communication, and the network security or the cyber security. We know, now we are during the COVID-19. So there are some strong indications during COVID-19 outbreak, lockdown period that many computing and communication technologies will see accelerating adoption in the coming years. And now we are also conducting this or online seminar or online webinar. So the Internet of Things devices promises to improve the efficiency in the smart and secure environments such as smart cities, smart grids, smart farming, smart factories, military, smart transportation, and smart healthcare and the environment, and creating a new opportunity for the home and the rural development. So most of IoT devices are cloud-centric now and are characterized by device-to-device communications, device-to-cloud communication, and device cloud analytics. So the IoT applications having challenges is the smart and secure environment, such as the poor bandwidth, poor connectivity, latency, not compatible with the cloud-centric architecture. So the key element of implementation of industrial Revolution 4.0 solutions is the next generation of network connectivity, smart computing, communications, to improve competitiveness of various industry and the sectors through the Internet of Things devices, gathering a huge amount of real-time data and the big data analytics. So outline of this presentation will cover a brief overview of the smart computing and the communication, functional interoperability of the Internet of Things devices as computing, quality of service, future research direction, and the challenges within the context of the local, regional, and global environment such as home, factory, vehicle, office, airport, or COVID-19 or similar outbreak. So this one is the Gartner Top Cycle Trend 2018. Gartner is one of the IT company. You can say this is the website where the information is available. So this is one of the IT researcher company, and the Gartner gives the divided into three different dimensions. One is the digital, intelligent, and the math. And digital again divided into four different dimensions: digital twin, cloud to edge, conversational platform, immersive experience, AI foundation, intelligent applications, Internet of Things, blockchain, uh, event-driven, and the continuous adaptive of risk and the trust. So in this presentation, we will discuss about the digital things, cloud to edge, AI foundation, Internet of Things, as well as the security part. Now again, Gartner in 2000, Gartner also gave the 10 top strategy technology trends in 2020. In this one, this research divided into two different parts. One is the people-centric, other is the smart spaces. In people-centric, there is a hyper-animation, multi-experience, democratization, human-augmented, transparency and traceability, empowering edge, distributed cloud, autonomous things, and the practical blockchain and AI security. In hyper automation, automation use technology to automate tasks that once required people to do those tasks. So hyper automation is about using the technology like artificial intelligence and the machine learning to further automatic process. And I think other two speakers will also give some detailed emphasis on the artificial intelligence as well as the machine learning. So multi experience focus on how people interact with experience and control with digital world and the applications. Democratization here is technology means the people giving easy access, technical or the business expertise without extensive and the training. That is very important, because the training is not extensive and it is not easy. It is very difficult to understand for all of the community. Transparency and the traceability. Transparency, traceability here is uh, uh, in human augmented is about the technology to enhance the person's cognitive and physical experience ability. Transparency and the traceability, the development in the technology are creating a crisis of the confidence of consumer. Becomes more aware how their data is collected and used, which is why business are recognize the increasing responsibility for a strong collection of their data. And this one is I'm emphasized on the smart spaces side today in my presentation. Here is the smart age. So these days, edge computing is computing topology where information is processed and content collection and delivery take place closer to the source and the consumer of this information. That's important. So keeping the traffic local and distributed. The idea is to reduce the latency, expand the capability, and improve the decision. The edge refers to all technology built into IoT in the world around us, and empowering the edge tools to how these devices increase the and the form of basis of smart spaces, moving important among of applications and service closer to the people and devices use them. By 2023, there are many more than 20 times as many devices on the outskirt of the network conventionally IT role. This is also important. Second part is the distributed cloud for the research right now. So and we know distributed in terms of the blockchain or other things. So the distributed cloud refers to the distribution of the public cloud service to locations outside the cloud, provides physical data centers, but are still controlled by the cloud. That is very important. Next one is the autonomous things. Utilize AI, artificial intelligence to perform the task about usually performed by humans. Thus, one looks at how AI and machine learning enable autonomous activities on physical things, such as the drones, robotics, and car and the ships that we'll discuss in a couple of slides. Next slides. Practical blockchain. Now we are using also the practical, Now it should be the practical, everything. Here is the AI security. Now we are not dealing with the security. Now we are dealing with the AI security. So the practical blockchain is the type of distributed ledger. And expanding the chronological order list of the cryptographic signed uh, immutable and transactional records shared by all the participants in the network. And the AI security increase the number of AI solutions and the potential point of attacks via Internet of Things devices and highly connected services created a true security challenge. This is the Gartner Hype Cycle, here emerging 2007. So here the Gartner Hype Cycle Gartner Hype Cycle gave this access is the technology. This one is the visibility. So in particular, this emerging technology 2007, here is starting is the AI general intelligence. This is the triangle arrow. It means more than 10 years to reach up to the plateau value or the maturity value. So since from 2017, this particular technology, AI general technology, will take more than 10 years to reach up to the maturity value. Edge computing will take more than 10 years to reach up to the plateau value or maturity value. IoT platform will also take 2 to 5 years to reach up to the plateau value. This one is connected home will take 5 to 10 years to reach up to the maturity value. Autonomous vehicle, again, it will take more than 10 years to reach up to the plateau value. And this is the still software defined security. This is also take 2 to 5 years. So this is not full Gartner Hype Cycle. This is the partial Gartner Hype Cycle, but we will explain on these areas. That's why I have included those areas in this particular hype cycle. There is another Gartner Hype Cycles for emerging technology 2019. Here is you see here this one is again this one is time axis. This one is expectation axis, and here is the autonomous. Now autonomous driving level like autonomous car or something, you heard about those cars. Now this particular emerging hype cycle divided into 2 levels. This is level 4 and here is level 5. So it means the level 4 is fully automatic and the level 5 is semi-automatic, something else. So it's divided. Semi-automatic means one is without driver and other is without driver. And other things also related with the timings. This yellow circle shows that it will take 5 to 10 times to reach up to this plateau value or the maturity value. So the role of AI, machine learning and smart sustainable development. Participants are requested to please mute their mic. So the role of IoT, AI, machine learning in smart sustainable development, the combination of high speed, resilience, low latency, connectivity and technologies such as IoT, artificial intelligence and machine learning, which enables the transformation towards sustainable smart cities. Sometimes, some students ask many questions. You see, what the difference? What is artificial intelligence? What is machine learning? What is deep learning? And what is the criteria? What is the difference between these 3 different intelligence systems? So that's why this particular slide gives the difference. The artificial intelligence, any techniques that enables computers to mimic human intelligence using logic, if-then rules, decision tree, and machine learning, including the deep learning. So this one covers all another 2 type of intelligent things. And the machine learning, a subset of artificial intelligence that includes the complex statistical techniques that enable machine to improve a task with experience. So the category includes the deep learning. And the deep learning is also the subset of the machine learning, composed of algorithms that permit software to train itself to perform tasks like speech and image recognition by exposing multi-layered neural network in the amount of data. So this is multi-layer. I will explain later on what do you mean by the multi-layer neural network. In the if you, initially we had near about 70, we had about neural network. Then it was from 90 to 2000. It was very useful. But 2010, 2000 to 2015 or 18, neural network was not in the research market. But again now it's becoming popular now, because now what we have now, we have a now we have a high computing devices. So in neural network, we know we have a different type of layers. One is input layer, in between the hidden layer, then the output layer. If you want to increase the hidden layer, then there is a complexity increase. So we need a high computing devices. So now all the systems have a now high performance, and we also have some high performance computing devices like supercomputer, mainframe, or other type of computing devices. So now we can increase the hidden layer, we can increase the complexity, we can develop the algorithm by deep learning concept. It means the deep learning is subset of machine learning. Machine learning is also subset of the artificial intelligence. Just I want to give the brief introduction about the machine learning. What do you mean the machine learning? Sometimes students also confused about the machine learning. I think most of the students are from computer branch students here are the students in this participation. So this is one of example. This is the crop field. Generally in Namibia, there is a crop of the maize here somewhere. This is the rainfall, and this is the predict crop. So based on the rainfall, how much would be the crop yield that we need to find out with the machine learning. And in this case, what we are doing, a variable whose values does not change by the effect of other variables and is used to manipulate the dependent variable. Sometimes we call dependent variable in a symbol. And other is the variable whose values change when there is a manipulation in the value of independent variable, and it is often as y sometimes. So here is crop yield depends on the amount of rainfall. If there is a less rainfall, then crop is less. There is a sufficient rainfall, then good crop, and there is a excessive rainfall, then crop is not good. So those are the main different parameters that we can consider in the machine learning. Now I'm coming in the Internet of Thing devices. We know the networks of the physical object that contains embedded technology to communicate and interact with their internal state or the external environment. Professor Nayak already explained about the type of the big data generated right now in the future. You see in this particular graph, this statistics I took from the Cisco VNI Global IP Traffic Forecast. And in 2016, 3.3 billion internet users were connected. But it will be expected that in 2021, 4.6 billion users will be connected with the internet. Similar with the devices, in 2016, 17.1 billion devices were connected, but it will be expected that in 2021, 27 billion devices will be connected. It means now it's 20, and the population of world near about 7.5 billion. So it means every people will have 3 or 4 devices according to this statistics. This is the capacity, and this one is the again important graph here. Now we are using all the smart devices. You have smartphones. Everybody will have now smartphones. Now we are not happy with transmitting the text to our colleagues. So what we need, and still we are not happy with receiving or transmitting with audio. So we want to stay with the video. So right now the most of traffic in 2016, the 73% traffic was the traffic of the video, and it will be expected that in 2021 it will be 82% of the traffic is the type of video. So it means if you want to transmit or if you want to download the video, then we need a high bandwidth, and this is the requirement of the bandwidth. So we need to take care. We need to solve the problem, especially when we are transmitting the video or the big data on the internet. This one is global mobile traffic data generated. Here is another statistics. So now we see this one is the web data, audio data, and the video data. So in 2017, only 4.17 exabyte data were generated, but it will be expected that in 2021, 36.38 exabyte data will be generated by the video. I think that I already explained. This one is so that now now we need to know that what is the Internet of Things devices and what is the things. Here you see the Internet of Things was born sometime in 2008 and 2009, where one people will have one IoT devices in 2009. But in 2020, according to this another study, 2020 and of 20, and now it's December. We don't have any other statistics, but we need to explain. We need to take this particular report is in the correct way. So according to this report, 6.58 billion devices will be connected to each and every people in the world. Now we know the people connected to the things. Already the chief guest and other speakers, Mr. Vyas and other dignitary, they explained that body area network or something. So now if you are running, you are equipped with the different type of motion sensors and the EEG sensors. Your live data is going to update on the internet. Your doctor can be sitting somewhere here, he or she can access, and you can also, and your doctor can also access your information. So it means you are also connected with the network with the means of different type of connectivity. Here you can say the GSM connectivity, 1G, 2G, 3G, 4G, 5G, or whatever connectivity you have, or another type of connectivity. If it is in the campus, then maybe the campus network connectivity. This is another things connected to the things. Here car is connected with the police, as well as the petrol pump and the service station. If you are running on the road, you need immediate help for the service station. You need to contact in advance. You need to book your time and slot so that you can save the time. Using different type of wireless technology that are available at that particular areas. So maybe connectivity, maybe 3G, 4G LTE, 5G, Wi-Fi, or the GSM or other tie or satellite connectivity. If you need assistance from police, you are also direct connected to the police, so you need to call the police if there is assistance. You can also connect to the petrol pump. Okay, you should be ready. I'm coming. So the petrol pump is also ready, and petrol pump can also book your slots while you are there. So in this case, all the things are connected with the things. I have vehicle to everything. Here, this is the car is connected to the vehicle. Always also connected to the mobile tower somewhere here, and also the pedestrian. So this car is also connected to each and everything. This is one another important market size estimation by 2020. In this case, this is the IoT market size estimated by 2020 by Cisco, IDC, and Gartner. So I compare this particular market survey for you, because you see in this case we have three different companies, IT researchers. Cisco says the 50 billion devices may be connected in 2020. This IDC said 32 billion devices will be connected, and according to the Gartner, 26 billion devices will be connected. Now the question is which one is the right, because it's the 26 is the 50. So if lowest one is the right, so we can take this 26. If this 26 devices will be connected at end of the 20, it means now we have a population is 7.5 billion. So every people have near about 4.2 or for something IoT devices, and the device is connected to him or her. Or here is the market. Sometimes during the research and the market survey, where we need to go for the future business or for future services. So according to this market survey, the IoT market is, according to the Cisco, there is a 1 trillion US dollar. But again, according to the Gartner, the market is 1.9 trillion dollar. So this is the difference. Here is the 19. Here is the 1.9. But if you consider this 1.9 US trillion dollar is a huge market. This particular slide is regarding the security. You need to know what is the security issues and how much amount we need to spend on the security part. So I'm not going to explain on the lower side, but if you see here on 2021, so worldwide IoT security spending forecast is 3,118 million US dollar. So you see it's a huge amount this one is. This 207 is for the professional services. This one is for the gateway security, and this one is another endpoint security. So this amount is also a huge amount to spend the security, because now everything is on the internet, and the security is the major issue, and we need to deal the security issue. By 2021, global IP traffic will be reach an annual run rate of 3.3 zettabyte per year. So it's not big data, it's huge it's data. So what's the solution? So this is the sensor cloud technology. It's popular particularly for dependent of IoT environment and integrated in two different technologies. One is the sensor technology, other is the cloud technology. We know this is the sensor technology includes the sensing unit, processing unit, as well as the communication unit. And these are the some applications that we are using these days: target tracking, wide monitoring, healthcare, industrial, smart home, smart cities, smart agriculture, and other disaster management system like COVID-19 or some other disaster. So these particular slides compare with the two different technology. This one is the traditional using wireless sensor network. This is based on the sensor cloud. In this sensor cloud, there are multiple service applications and there are multiple users. Here is the virtualization. So here is the sensor cloud infrastructure. So multiple user can access the multiple applications. Here only single user can access the single user. So that is the beauty of sensor cloud technology. Now, what is the problem of the cloud? We know the problem is the latency, because maximum speed is the speed of light. It is 3 raised to power 3 into 10 raised to power 8 meter per second. Bandwidth is also the problem. Explosion of data should be much local. Autonomy 100% uptime. If it is not uptime, then we have to wait or something. So we need 100% uptime. Privacy is intimacy of a data. So by the latency here is this is the edge devices. This is the processing time. This one is T1 is the processing time. T2 is the communication from edge to the cloud. T3 is the processing time at the cloud, and the T4 is reverse back from cloud to source and the edge. So the total time is T1 plus T2 plus T3 plus T4. So this one is the complete propagation time. So this is a latency, and latency is too high, then it create a problem. And if you don't have a right solution in right time, then this create a problem for the emergency applications. So what we need to do? So near about 2013, Cisco coined a term is fog computing. So in there is another computing after this cloud, this fog. So this is an intermediate layer extend to the cloud services, intermediate in between the cloud as well as in between the device. So why we need a fog computing? You see, the current cloud cannot handle all the data, and data need to be filtered at the edge. So here we have the different applications: the ambulance, research centers, streaming media, private firm, industry. Those are some applications in smart cities and smart rural. And you see all those applications are generating the huge amount of data, and every data we are going to transmit to cloud. So the cloud server cannot handle those data. So what we need to do? We need to filter here somewhere in the cloud, or we need to transmit, or we need to another intermediate layer in between the cloud and in between the edge. We already discussed there is a latency problem. If you want to transmit all the data to the cloud, and there is also the another the bandwidth also a problem. You need a bandwidth. Here is the application, ambulance. Sorry, this one is ground transportation. Those are the different applications. So now I'm using one example for you. Suppose one patient is running on the road, and he need immediate response from the cloud services. So what we need to do? Patient need to sending the time sensitive data for analysis to the cloud. So there is a processing time at the ambulance. There is another propagation time to transmit data from this ambulance to the cloud. cloud again process these information and give response to the feedback. So there is another process time, and there is another communication time from cloud to this ambulance. So the total time is too much, and the patient is in the ambulance, and patient need immediate action with the cloud, and patient need to receive immediate response, otherwise patient may be dying. So that's why we need a computing at the edge, or the fast computing, especially for the time sensitive applications. And we also need a high bandwidth, and necessary we are transmitting all the transmit data to the cloud. So we need to filter the data at the cloud end. This is one of the four computing architecture. Here is something is time sensitive data need to submit directly to the cloud if there is insensitive data. If time sensitive data, there is a nearest fog. Nearest fog will give the immediate response and still need to be transferred to the cloud. If less time sensitive data, there is another aggregator node, and summary need to transfer to the cloud and give the response to the edge devices. And now we are also working at the edge. In addition to the fog, there is a problem with the fog in the security part. We'll discuss later on. So what is the problem in the fog computing? The main security are authenticated at the different level of the gateway. So there is security issue. Issue is the man in middle attack. So we cannot implement all the cloud security at the edge. This one is the global smartphone devices connected with the network. Now you see, this one is the smart devices. This one is not in smart devices. In 2021, it will be expected that the 25 billion smart devices, non-smart devices will be connected, and the 75% billion smart devices will be connected according to this study. And we know the smart devices is generating the huge amount of data. So in 2021, 40 exabyte data will be generated by the smart devices. Only 0.26 quarter fourth exabyte data will be generated by the non-smart devices, because every people have these days the smart devices now. You heard about the smart cities and intelligence. Even though now we are talking the smart, and some of the Indian cities are also selected as the smart cities in different perspective. But you see, what do you mean by the smart? So in the smart, computer electronics put together can make the smart cities. We have different entities in the cities, that like transport, railway, police, hospital, traffic, banking, educational, and the waste management. So those offering service to the citizen. So in this case, these are the smart services for you: smart governance, smart mobility, smart building, smart energy, smart technology, infrastructure, as well as smart healthcare and the people. These all connected with the sensors, sensor networks, actuators, and the connectivity. So I'm giving now example. For example, your brother sister is going to the school in the morning, and something is maybe happen during the way. What will happen? Immediately at that time, police need to be informed, hospital need to be informed, parents as well as the school need to be informed, and other relevant service providers need to be informed, so he or she have an immediate response. So that is the smart. So everything should be smart. Now we are also moving toward the Industrial Revolution 5th, or now we are working on Industrial Revolution 5. But Industrial Revolution 5th, what we have to do, we have to enter the intelligence system. So now the smart need to be replaced by the intelligence. We need intelligence solutions. Either we have to use the machine learning or machine learning for the intelligence system. You heard about the Google car here. This car equipped with the digital camera. This is the light detection and the ranging sensors. Here is ultrasonic sensors. And this car is connected via GPS as well as the satellite connectivity and other type of connectivity, and your server updated on live. So I also visited last year in US, and I saw one of the car, Tesla car, automated car. But still we have a problem with the security. and other problem because everything is data. So some incident also happens. So that's why now they are divided into two different categories, L4 and L5. L4 is the fully one category is the fully automated, another is the driverless that assists to the driver while doing the driving. So these different sensors can guide to the car while traveling on the road, and live data is updating. So you heard about the Google car research project, and whole world is working on the Google car. And that's why they are using something Python or other Python in machine learning to develop some artificial intelligence solutions. Uh, this is specifically, what is the importance of the artificial intelligence, machine learning, and the Internet of Things devices, especially in disaster management. Now, the question is how IoT-enabled devices can help to fight COVID-19 pandemic. What are the objectives for some of couples of slides? How explore how current artificial intelligence-enabled drones applications improve performance and increase efficiency in the various situations to fight COVID-19 outbreak or similar situations, gain insight on the future AI-enabled drone and its increased role of fighting COVID-19 and other applications, understanding how specific business problems are addressed by innovative machine learning mathematics. This I also want to explain. The last one is explore how 5G is not accelerating spread of new coronavirus because we heard about that one musician in Europe, she said that 5G is generating coronavirus. So how AI can help to COVID-19 crisis, but the right human input is the key. So AI can help address viruses if applied in a creative way. Creative way. It is set up as to identify new and innovative way to the leverage what artificial intelligence can do. This is one of the IoT police robotic for monitor to COVID-19 pandemic. A police robot has been deployed to patrol area of Tunisia capital, Tunisia to ensure the people are observing a coronavirus lockdown. So this will help minimize physical contact between the police and the resident patient with COVID-19. There is another application in China. Here is this is infecting robots, smart helmets, and thermal camera equipped drone and advanced facial recognition software are being deployed in fight COVID-19 at the heart of the outbreak in China. Uh, you know, uh, South Delhi Municipal Corporation staff used the drone to spray disinfect in Nizamuddin, Hazrat Nizamuddin in Delhi. This is one of the drone. So the drone is taking the video directly from here is some people, and drone can be manipulated, drone can be computed. But you see, what is the problem here? Still, we have a problem, and there are various challenges. So first challenge is the connectivity because you are at the edge, you are controlling this robot somewhere, so you need a connectivity. And robot is also taking a picture. Suppose some terrorist is here or some unbehaved user is here, someone, and robot will take the photo. It will transmit to the edge devices. Edge devices need to be computed and give the response. Okay, within the short time. Otherwise, you see, the people can move from another places. And if we have a many robots, because there is a limited area, we have a many robots, so there is also the issue of interfaces. There is also issue of the weight or other things if something is happening because we have a less control on the robots. So a lot of research need to be done for the robotic and the drone technology. That I think we already explained about regarding the drone. This is another application during the disaster of the IoT, unmanaged aerial vehicle and remotely piloted aircraft systems for health monitoring and detections of the infection and respiratory conditions we use during COVID-19. This one is another application because I am running behind the time. So to make the drone is valuable and the reliable technology for the different industry, much work need to be done. Drone and the other sensor equipped devices produce raw data that require computing analysis to make the data useful and actionable without human intervention. So now the edge computing stack and IoT application platform that enables analytic machine learning and the seamless deployment of the code and the movement of data across the edge and the cloud. Now another that we already discussed about 5G. 5G, not the reason that you see, one of the musicians in Europe, she said that, okay, why COVID-19 has not affected Africa as it is not a 5G region, but it is affected in other countries where 5G is there. So 5G is not the reason that Africa have not affected. African countries most COVID-19 readiness to response many confirmed cases. So appropriate precautionary measures were taken to deal with COVID-19. I'm in Namibia still. Now we have some cases even, but the cases is not like India. Why cases is not like India? Because in Namibia, this is less population density. You can say in every 3 kilometers we have only one person. So the geographical area of Namibia is 25% of the India, but the population is only 2.5 million or 25 lakhs population in Namibia. So that's maybe the another reason that we don't have so much COVID affected cases in Namibia, but still we have some cases in Namibia. And we work from home. Last week we visited in the university. Now we have, but still the classes is also online. We are conducting all the classes online. So now what we need? We need another type of computing, the edge computing here, because there is a problem in for computing regarding the security, and we need to filter the data. There is one another standard is going to develop by the IEEE. This is 1931.1. Rope computing is still in the process. So this is some conceptual framework. We'll use either this one is the device management network, things network, security, as well as the cloud connectivity. And the architecture of this one, this is the cloud, here is the fog, and this is the roof. So we need another edge computing. So we need to compute each and everything as the egg, and yesterday need to be transmitted to the cloud. And if there is, and those devices is connected to the edge devices. So our world is moving for the edge devices, and they are developing a particular application specific devices, and all the computing part, most of computing part is at the edge. But the question is, because last year I presented my talk in one of IEEE conference in US, and one of IEEE fellow, he asked that he's not agree with another for computing. So I discussed with him why we are transmitting all the big data to the cloud. So we need to filter the data. Then he was agree. Okay, yeah, filter is fine. We need to filter all the data if there is no need to transmit to cloud. So of course we need another type of layer. So there is a lot of research we have to do at the edge layer. And we also working for HPC rack, high performance edge devices for the research purpose, and that gives the high performance computing and complex computing facilities at the edge. So the conclusion of my presentation is the intelligence edge of the founding of future digital business and its ecosystem, as computing is still in its early stage and has potential to discover the way for more efficient computing technology for enabling future Internet of Things. Machine learning as computing devices includes robots and drones can contribute to emergency situations. And 5G is not accelerating spread new coronavirus, and we need 5G to implement the new technology, especially during the drone and other technology. And these days we are using all the IT technology regarding the video conferencing for online remote teaching and learning facilities. So we need a 5G or improved connectivity for communications. Thank you. Now the floor is open for the questions.
Thank you, sir, for sharing your vast knowledge with us. I request participants, if you have any doubts or queries, please you can ask. Feel free to ask. I once again request all the participants, if you have any doubts or queries, please ask. You can ask in chat box. No questions. Acha.
Okay.
So someone has asked about QoS services in cloud.
So you see, QoS, that's why you see, I already explained you quality of service in cloud means we use, what do you mean by QoS? QoS means you need to reduce the delay, you need to reduce your jitter in the network, that is the quality of service for time sensitive applications. So in this model, if you want to employ the quality of service in network, because now we can say the cloud cannot handle the problem. There is a problem of jitter. There is a problem of bandwidth issues. So we need to improve those things, and we need to create another layer as the edge layer, and we need to solve those problems as the cloud. Data need to be filtered at the edge, and only still need to be transferred to the to the cloud. So we can improve the quality of service as the cloud server. Is that right? Are you
Yes, sir.
satisfied?
Yes, sir. Someone has asked how to simulate it.
Okay, this is the another. You see, now we are simulator. iFog is the simulator right now. Many people are using iFog, but you can also extend the simulator for your research work. You can develop something using Python, or you can develop your own simulator. But initially you can use iFog simulator or other simulators for this purpose.
Okay, sir. I hope doubt is solved. Sir, someone has asked why we are not using end-to-end encryption in fog computing.
You see, now encryption is also there. You see, we can use the end-to-end encryption, but you see, now there is a in fog computing. Okay, you see, fog is distributed. Now there is a cloud, and fog are the another servers at lower layer. So fog are distributed. Maybe you can say 3-4 servers. So they are not under the control of cloud. So if we don't know the encryption and decryption algorithm, so we cannot implement those algorithms at the fog layer. So the same encryption and decryption algorithm or other improved algorithm that we are implementing cloud cannot be implemented for, but you can implement at the edge, because that is in your hand. So the same algorithm for the end to end, yes, you can use at the edge and you can use at the cloud. So that's the research you need to do.
Okay, sir. Thank you. Any other doubts? I think participants are done with the questions. Okay, sir. Thank you. Thank you so much for sharing your vast knowledge with us. Session was really informative, sir.
Thank you, thank you. I suppose Monica is speaking. Who is speaking?
Neha Tawri. This is Neha
Neha,
Tawri, sir.
thank you, Neha, and again I thank you to the prestigious institution who gave me this opportunity, and again I would like to thank all the organizing committee. Thank you
Thank
very
you.
much.
Thank you,
Thank you
sir.
so much, sir. Dharm sir. This is Monica. Thank you so
Yeah,
much for accepting our invitation and giving us such an informative session. Thank you so much, sir.
thank you. It's my honor.
Okay, then for next topic, I would like to invite Professor Preeta Sharan. Preeta Sharan. Before that, I would like to give brief introduction about Dr. Preeta Sharan, ma'am. She obtained her master degree from Banaras Hindu University and PhD from IIT Bhubaneswar, Varanasi. Additionally, she did her postdoctorate from IIT Kharagpur in domain of optical sensors. She has published many papers in reputed journals and conferences. She has visited many countries for research paper presentation in domain of nanophotonics, optical sensor and quantum dots. She is currently working as professor and research head in Department of Electronics Communication Engineering, Oxford College of Engineering, Bangalore. She has taken various funded projects from government funding agencies like NRB, DRDO, IEEE, ICMR Delhi, etc. Her area of research includes integrated optics, surface plasmonic resonance, fiber Bragg grating, quantum dots, etc. She has taken membership of technical bodies like IEEE, ISTE, IETE. We are pleased to have you, ma'am, over here. Dr. Preeta, Sharan, ma'am.
Yeah, thank you very much, Neha,
Yeah,
for my brief introduction.
yeah.
Yeah, I am very thankful to this Sri Sankaracharya Engineering College and Dr. Monica for calling me. So I am congratulating you, Dr. Monica, for
Thank
doing
you, ma'am.
so many activity under CSI chapter in your college. So I will share my presentation now. So you are making me host.
Yes, ma'am. You can share your screen, ma'am.
Yeah, can you see my screen?
Not yet.
Okay. So first I have to minimize, no? First I have to minimize.
Ma'am, you just have to, you can see three dots at the end of the bar.
Yeah.
You, just before that, you have presentation. Uh,
Present now. Yeah.
yes,
That
yes,
only.
ma'am.
A
Yes,
window.
ma'am. To get
A
a window,
window.
you have to click on the window and say share now.
Yeah. Share. Share option. I am clicking share, but it is not coming. Share.
Ma'am, you have to click on the screen first. You please select the click on the screen where you are getting your desktop. You have to select that and then say share now.
Okay. Now share. Is it share?
No, ma'am, we can't see your screen as of now.
Okay. No. So
Ma'am,
first,
when you clicked on present now, you have to click on your entire screen.
okay. Present now your entire screen.
Yes, ma'am. So
Yes.
when you click on your entire screen,
Yes.
you get the screen. You click on the screen.
That only.
Can you see your screen? Where it is, you get a window where it is written share your entire screen.
Yeah, that I got.
Yeah, ma'am. So there is your screen is being shown. You click on
No,
that
that only
and then
not.
say share. So as soon as you click on the window, ma'am, you will get the share. Yes, we can see.
Oh,
We could
it
see it
went.
that time, ma'am.
Oh, it went. Your entire screen,
So
and
you
then
click on that window, ma'am.
that
The window
window
which
is.
has, can you see your screen there?
I can see your screen now.
Yeah. So click
Yeah,
on it
yeah. I click there.
and then, ma'am, the share button must have
Yeah,
got activated.
yeah.
Click on
Button
the
up.
share button.
Share button.
Yes, ma'am. Now we can see your screen, ma'am. You can start the presentation.
You can see my screen.
Yes, ma'am. We are able to see your screen. You can start your presentation.
Yeah. Can you see my screen now?
Yes, ma'am. It is visible.
Okay, fine. Fine. So today's my topic of presentation is optical sensor with AI and ML. So basically, I am going to give the elaborate presentation on the optical sensor, which is very important for the biosensing application as well as for the. I have taken the example of the water. Inside the water, if any chemical impurity is there, how to design that sensor and how it can be implemented with AI and ML. This is what. So before starting my talk, just I want to give a short introduction about my lab. So basically, this is my R&D center lab, and totally funded by the government of India through various funds. And this is my area of research. My area of research is optical sensor and optical network, optical data storage, and quantum dot and quantum computing and biophotonics. So I have selected today's topic is biophotonics. So this is the background of our R&D center, where under me 6 PhD students already graduated, and many MTech students are there, internship students, and these are the funding agency. I am very thankful to the government of India for funding me Naval Research Board, DRDO, IEEE USA, government of Karnataka, VGST, Indian Council of Medical Research, and AICT. Recently I got RPS fund. So with this many fund, I have my R&D center in the Oxford College of Engineering. The management is very much supporting to do the research and bring more funded work. So these are the few awards, which is nothing but outcomes of this research funding, where students are getting benefited. And because of that, I travel a lot of country, and this these are the country where overseas travel. So just I am showing this device, this slide, because just to inform that all any if any researcher or students want to travel across the world, they can travel, and it is funded, totally it is funded actually. So wherever I used to go, it was funded by DRDO or by WI, Women in Engineering, IEEE, or by Science and Engineering Research Board, SERB, and I went to University of Limerick, Ireland, and totally it was funded with the uh, government of India funding. So this is the agenda of my talk. I will give the introduction about optical sensor and the patent and publication and the motivation, objective, and the case study of one case study I have taken for today's talk. So basically, photonic sensor or optical sensor. So we are working in this domain, sensing. So basically, photonic crystal we are using to design the optical sensor for lab on chip. So what is the meaning of lab on chip? When we are talking about lab, so if we are talking about biosensor, then this lab is nothing but pathology lab. If we are talking about water analysis, then it is nothing but forensic lab. So that lab itself we want to bring on the chip. So we are going to design the chip. So we are working in the sensing layer, and then finally it will be processing and the display. So this two we are not contributing much towards the display, and we are working towards the sensing and the processing layer. So basically, what is photonic crystal, on which today's talk is totally based? So photonic crystal can act as a sensor by implementing defect engineering. So photonic crystal is nothing but it is a periodically varying refractive index. So how it looks, I will show you in the next slide. So research progress has been done, which will lead to develop a unique sensor by using this photonic crystal. And the main focus area of our investigation is sensor design, so simulation and analysis, because the total size of the photonic sensor or optical sensor is in terms of micrometer. So you can understand, we cannot go directly to the fabrication lab and do the fabrication without simulation. And after packaging also, it will come into centimeter or millimeter size. So one should be very careful while doing the modeling and simulation. So our main effort is towards the modeling and simulation, which even computers, because totally we are working on the Ubuntu platform. So operating system is Ubuntu, and here I think mostly students and a researcher are basically from the computer science background. So they may find some interesting input. And we are working by taking the open source tool, which is nothing but meep tool. Which is any CS student can take that tutorial, and they can also design the sensor. And after designing, if they will give, they can fabricate in Indian Institute of Science Bangalore Sense Lab, or IIT Mumbai. They can fabricate, or else if they do not want to go anywhere, they are in foreign country like University of Rochester and Canada, they are also taking the design. And your, if design parameters are very accurate, then totally they are going to fabricate, and they are going to send the sensor, and characterization can be done in any ordinary lab. So this is the main research area, and the design can be broadly applicable to a wide range of fluids. However, our emphasis is sensor used for water analysis and biosensor for lab on chip. So these two case study I have taken, water analysis and the biosensor. In biosensor, when we will talk, then different type of disease we can do, but I have taken for the sugar monitoring system. Some researchers are working on the cancer cell detection, some researchers are working on the creatinine level, but my topic for today's talk is for the sugar monitoring system, means blood sugar level. So the main objective is to design optical sensor and run simulation using available water and biosample data. So we have, I have divided this into three category. So first, we have to go for the, any researcher for the beginner, first they have to go for the sensor optimization. And when, and once sensor optimization has been done, then next level will be the smart processing and display. In this smart processing and display, AI and ML will come into picture. And this is a new technology, AI and ML, but from the traditional method, till now we have not it is not commercialized, and whoever has done, they have not implemented AI and ML with the photonics, because now few researchers are going to do work on this area. And in our research work, what we have done, we have tried to enhance the, or improve the sensor sensitivity from the previous literature survey, so that it can be able to fabricate. Because for the fabrication, it is very important to uh, put effort for the two factor. First is sensitivity, and second is q factor. Q factors value should be very very high. You can see here the value obtained is 11,508, which is very good q factor. So we have to go through this process. So in first process, sensor optimization, and then smart processing, and then we have to see that whether sensitivity is improved, then we can go for the fabrication level. And methodology. So everybody will definitely want to know that for the this optical sensor design, what methodology people are adopting. So the back end of this optical simulator is worked on the finite difference time domain. So we have to do modeling first. So in the modeling, finite difference time domain algorithm will run in the back end. So and the machine learning. And in design process, photonic crystal and SPR, there are two technology based sensor we are designing. And simulation we will use by using the MEP and MPB tool. So this MEP and MPB tool, MEP full form is Maxwell electromagnetic equation and propagation, and MPB for the photonic, Massachusetts University, they have done USA. So by that name, M word came, and P for photonic, B for band gap. So for the photonic band gap. So this MEP and MPB tool is open access, and freely it is available in the Google. You can download, and operating system Ubuntu you have to use on that. These packages you have to install, and you can design the structure for the sensing scheme. And finally, like IPK software is there. With this software, we can design the total how it will look finally, and then we will send to the fab lab. So this is the total method. So what finite difference time domain will do? It is a numerical method for modeling electromagnetic wave propagation through the sensor, and this photonic crystal design involve PBG. Certain frequency it will pass and certain it will stop. So basically, what PBG will do, what photonic band gap will do, what is the basic mechanism of this optical sensor? What will happen? Like in semiconductor technology, there is a conduction band, valence band, and forbidden gap. Unlike that, in the photonic technology, it is not like a conduction band, valence band, and there is a forbidden gap. There is only one forbidden gap, where it will allow one frequency to pass and other it will stop. So which frequency is allowed to pass, we know that which frequency is allowed to pass, we will store in our database. And then if any unknown disease patient will come, we will take the blood test and we will match with this. If it is matching, then we can say yes, you have the sugar level of type 1 sugar, type 2 sugar. Or if you are working for the cancer cell, so you have the breast cancer cell is present in your body, or cervical cancer. So we have to take the refractive index of that particular cancer and we will use in our simulation. Next. So basically now modeling. So in modeling first, what we have to do, so photonic technology is associated with signal generation, processing, transmission, and detection, where the signal is carried by the photons. So what we will do, we will use the light source, and light source we will use as a laser light. This laser source, also various type of lasers are there. Depending on the application, we will use the optical source, and it will pass through the optical waveguide where we are contributing. Our sensor is nothing but optical waveguide, and finally it will be detected by the optical spectrum analyzer, OSA, which is termed as in general light detector. So this is the basic equation behind this photonic crystal based optical sensor. So in photonic crystal is a structure that could manipulate beam of light in the same way semiconductor control electric current. So what will happen, you can see this equation is known as the master wave equation, and it is obtained by using the Maxwell 4 equation. So you can see that here in denominator epsilon is there. Epsilon means nothing but epsilon is equal to n square, which is the refractive index. So if you have epsilon, change in epsilon, so there is a change in omega. Omega means 2 pi f. F means frequency, so there is a shift in frequency. So if you are keep changing the epsilon or keep changing the refractive index, then definitely there is a change in the frequency. So this act as a sensor. So this is the main uh, uh, mechanism behind the optical sensor. This is because refractive index is a optical parameters. So we have to search the if it has been observed that from the literature survey, that if the person is having the not having diabetic or glucose concentration high in the blood level, then their refractive index of the blood is different, and the sugar affected person is having different refractive index in their blood vessel. So that we have to bring to the that we have to collect the data refractive index, which is many researcher has already find out, uh, and that refractive index we have to substitute during our coding by using the meep and mpb tool, and we can see the shift in the wavelength, and how much there is a shift in the wavelength, that calibration we will to do, and in this way we can design the optical sensor. So this is all about the modeling. So I talk about how optical sensor technology is working, and what is the basic formula and how to model it. Now I am coming on defect engineering. So you see that if we are doing the defect engineering means to remove the number of rod or holes. So what will happen, see that without defect engineering, this is the red color graph where stop band is more. Stop band means in external circuit there is no flow of current, no flow of light, and by doing the defect engineering, pass band is more. You can see blue color graph. Pass band means there is a flow of current in the external circuit. In our case, there is a flow of light, a flow of photons, photocurrent in the external circuit. So it means that we have to go for the defect engineering to just get the pass band more. So so what is PSC means? Photonic crystal. So how it looks, you can see that these are the photonic 1D and 2D and 3D photonic crystal. So basically it is a periodic arrangement of refractive index which allows engineering or propagation of light. So if the flow of light is in the two direction, it is 2D, and or else if it is in the three direction, X, Y and Z, then it is the 3D photonic crystal. And finally, how after doing the modeling and simulation, it looks like this is done by the Python programming and using the IPKIS software which will work on the Python. So after getting the output from the MEP, which is based on operating system Ubuntu, we have to import the data, and finally we have to make the IPKIS by using the IPKIS software. So it will look like this. So you can see that these are the port and this line defect we have done. So this we have designed, we have to send for the fab lab. And if all the parameters or everything is correct, then it is going to be fabricated. So some case study I have taken. So this paper I presented in Japan in 2013. After tsunami, I went to Sendai, that place, and HTA conference was there, Humanitarian Technology Conference, and it was totally funded by WI, Women in Engineering. So what was the topic that time? It was very interested topic, detection of hazardous element. So there are a lot of hazardous element in the water. So as per WHO, World Health Organization, there are certain chemicals which is totally forbidden for the drinking purpose. So it is very important to know that what are those chemicals and how to detect that. And the title we gave that, mapping of aqua constituent using the photonic crystal based sensor. So initially I have taken that what is the drawback in the current technology, and it will take time for 3-4 days, and spot sample are to be taken to the laboratory, and time for analysis is 48 to 78 hours. This is the current scenario going on. Whereas in our this is called our, this is our photonic crystal, and this is rod in air structure, you can see that. So or else holes in slab, there are two configuration. So this we have taken rod in air configuration. So what rod in air configuration, how we are doing, we are taking a wafer, and by taking the etching, photo etching, these are the silica rod which you can uh, here you can remove the one set of rod, so it will create a line defect or you know bus waveguide. Okay. And the dimensions are given here. A is the distance between the two rod, and radius of the one rod is 0.10 micrometer. So and dielectric constant value is 12. So by using this parameter, we have designed this, and this is the outcomes of the MEP software, and the name is given as line defect. Why defect? Because we are removing one line of the rod, so defect we are creating in the photonic crystal. What is photonic crystal? Already I informed that periodic variation of the refractive index. How? You can see that here refractive index or epsilon is 12, here at air it is 1, so 12 1. In this way we are creating. Or else if it is air hole gap, so this is 1 and this is 12. So this is the way. And if we have to remove it, it means that in code level we will do everywhere 1, so we can create the line defect by using the tool, MEP tool. and these are the dielectric constant or refractive index we collected from the different website which are very harmful or hazardous element present in the water, which we want to identify through our design optical sensor. And these are the frequency shift we obtain by using the simulation result. These are the simulation result which we got after uh, this line defect running the code in meep or based on the ubuntu. So we have plotted the graph, so you can see that these different colors of graph are there, which is maintained in the database. So if at all after this which I have not shown here, so this particular graph will be input for our machine learning. So what we are doing that in machine learning adaboost or nabis, we have I will show you in some few slides which what we are doing. This we can give to the machine learning, which will identify the which will train the data, and we can say that okay, in this suppose lead chloride, okay, or else mercury chloride is present, so it will come. GUI also we have done. So okay, no, do not drink this water, so it will come by writing like this. So we can this is the place where I can say that interfacing of photonic sensor or optical sensor with machine learning, so that what will happen, the accuracy will be very very high, and we have calculate the sensitivity also, so we are getting very high sensitivity. So further any person who want to do the interfacing with the optical sensor output with the machine learning, or train the model in AI, they can take this work, because this particular result I have not trained our data with our prediction model. So it can be done in future. So these are the graph plotted for the lead component and arsenic component. You can see that, and different you can see the peak shift is there. So there is a shift in the peak. The shift in the peak will identified, and we can easily store in our database, and we can say that if unknown sample of water will come, and we can match this, we can say that okay, in this lead component are present, in this arsenic component are present. And very interesting thing about optical sensor is the sensitivity is highest order. It is after decimal sixth place also, if there is a change, it can able to detect it. This is the beauty of the optical sensor. The sensitivity is 10 to the power minus 6, and sensitivity of the fiber Bragg rating based optical sensor is 1.24 picometer per RIU. So you can imagine in such a less and weak input signal also able to detect by the optical sensor. So this is the transmission spectrum for the TDS and the mercury component in the water. So we have done for all possible hazardous element, and we have stored in our database. And then further this we will give to the machine learning for classifier. So this is sensor is highly sensitive, and change of 0.01 in dielectric constant, it means 0.01 0.02. If there is a change in the dielectric constant, it will shift the frequency by 0.001 and could be detected. So 19 element we have detected by using this method. Second case study we have done for the detection of the brightness of the water. Brightness means the salinity of the water. So water salinity is also very important factor to understand, because the percentage salinity as it is varying, so it is advisable that if salinity of the water is less than 0.1%, only it is useful for the drinking purpose. Then what we will do if the salinity of water is 10%, and it will vary up to 33% salinity of the water, then in that case a literature survey is telling that you can utilize this saline water for the medical purposes, for the agriculture purposes. So it is also important research work to identify the salinity of the water for the given water. So this work was presented in Global Humanitarian Technology Conference in Kerala, and it was well appreciated. So how the sensor will look like? You see that this is the photonic crystal based sensor, optical sensor, where we are contributing. We researcher are doing the simulation for this, and finally after fabrication, who will go for fabrication, they will sandwich this sensing layer between the substrate layer or silica layer and the superstate layer, and finally it is the four layer structure, air layer, and light will allow to pass, and with characterization which we are seeing in the laboratory, and output light will come output, so we can do the characterization. So this is the another structure. This is called holes in slab structure. You can see that holes. How we have created the holes. So in the nano center, IISc, Indian Institute of Science lab, you have to take the wafer and then you have to do the drilling, which is not exact word of drilling, but it is known as the ion beam lithography technique. So by using the e-beam lithography technique or FIB technique, focused ion beam lithography technique, you can do the very fine, you can create the holes, and one line you will remove that. So this is again act as a line defect or a bus waveguide. Fine, and the parameters for this are given below. So again, the percentage salinity, as I was talking, is observed, and we have collected the refractive index. This refractive index collection we have done from literature survey. Fine, and then we have used in our tool. We have written the code for the line defect to create this structure. We have written the code, and after the output, we got this line defect structure. So we have got the n effective value, and that we have maintained here. So you can see that we have collected the data from the 0.01 percentage salinity, which is allowed for the drinking water, up to the 30%. 30% salinity means not at all. It is very poisonous, not at all allowed for the drinking purpose. It is for the, people are using for the tourism industry or for the fountain for other purpose. They can be utilized, but it neither it can be utilized for the agriculture purpose or for the animal husbandry. This is our finding. We have done research on this. So this all are the graph of the detection of the brightness of the water. So you see that percentage salinity, if it is increases, and the effective index, refractive index also increases. This is the graph we are getting. So you can see that in our database we will maintain this. This is very important because these are the findings of the result. Here mathematical equations I have not brought into a picture because it will be boring for the audience. Just I have taken the result output only. So you can see that when 0.01% salinity is there, the graph is here, and when it is 3.5% of salinity, graph is here. So for the shift in the different salinity percentage, you are getting the different shift in the optical uh, an effective value. So this can be stored. This can be stored in the database. Fine, and then further we can train this. All graph are there. It means values are there. Obviously, graph can be plotted with the help of the x and y axis values. So those values we will give to the machine learning for the training model. Fine, so this much percentage we can easily able to identify. Again, so this is called the GDS2 layout. Those who are from EC background, they know the VLSI. VLSI industry is totally based on the GDS2, like a diode or transistor or anything. When we are teaching in the VLSI lab, then we have to explain that layout schematic, and after that we have to do the GDS2 layout. So if we are giving the GDS2 layout, then any fabrication lab, their work is just to fabricate it with our design parameter. So it is very important to learn how to do GDS2 and all our IPKIS, using IPKIS software we have done this. This some software I have purchased from Naval Research Board funding, which I got from 25 lakhs. So 15 lakh software is there from Synopsys company. So that software is known RSoft. By using that RSoft, some of the result is shown here. The importance of the purchased or licensed software and without licensed software is, only thing is that with licensed software directly it will go for the fab lab, whereas for the open source you have to do lot of optimization. For example, you see here, if I will show you in F5, then it will be better. Actually, light will propagate, light will pass through. So if light is not actually passing directly, it will spread throughout this. So how to make the light to pass exactly through the line effect, it is depends on your performance, how you are doing the optimization. Lot of effort has to be taken, lot of iteration has to be done. Rod r by a aspect ratio, and then we are getting this structure. So these are the light is passing. So these are our sensing layer. So you can see double ring resonator. So we are detecting the magnesium presence in seawater. These are the output still out we have taken. These are the graph presence of. Now we have next case study we have taken E. coli, present of E. coli bacteria in water. So because of shortage of time, I am going fast. And this is another software with RSoft, which is the purchased license version software. So this in RSoft, layer by layer deposition structure we will do, and the top layer we will present the E. coli bacteria, and we will get the ineffective values, and and 4 5 iteration we have done, and where we are getting the higher sensitivity, that we will select for the fabrication. So these are the sensitivity calculation has been done, and you see that 1071, this value is higher compared to all other pair, like you know AU gold and silicon, and AG and silicon. So AU and gold and gallium arsenide as a metal dielectric interface, this particular interface selection we will do, then we are getting the higher sensitivity. So this is better compared to other. So for this we have done this simulation, and these are the detection of the E. coli in water. So this two graph is showing with E. coli and without E. coli. So again we will maintain in our database, and if unknown water will come sample, then we can give, and where it is matching, we can say that yes, this water is dangerous, and here E. coli is detected. So these are the result, all result. Then DNA analysis. So see, our main aim is to, you see that, because I have not done in F5 mode, otherwise it will show that. So here actually we will put the blood sample. So our main, our no, full researcher is waiting for this to come, like plugin. So it means that in doctor will have in his mobile only, he will able to see suppose cancer cell, just by screening, by seeing that blood sample from the mobile itself, and the doctor will able to tell that, okay, you in your blood cell cancer cell are present, means you have malignancy or not. So that can be predicted. So one day will come, this is our vision. So these are the design factor, these are design parameters and design workflow. This is the structure. This structure is sandwiched between the substrate layer and the silicon layer finally. And you can see that this is the normal. I'm trying to do F5. So this is the normal cell, and this is the cancer cell. Okay, very clear cut, there is a shift in the wavelength. So you can see that by using this RI value of normal cell and cancer cell, you can able to distinguish. These are the cancer and normal cell. Then tuberculosis we have done. So if I will do in this in full screen, then it can able to show actually light propagation. I'm trying to do, yeah, you can see that. Yes, you can see now light propagation is, light is passing, and you see, you can see that how light is propagating. And in this bus waveguide and bend waveguide, we will put the tuberculosis, means blood test, blood, and it will interact, light will interact with the blood cell, and finally signature of that tuberculosis will come into picture, which we will store in our database. So these are the graph on, these are the way, if it has been observed that if person is suffering from the tuberculosis, in their blood cell the RI value changes we have taken from the literature, and then we have done the computational analysis, and we got the normal blood cell and the affected blood cell. We have plotted this graph. So this is the transmission spectrum. And again this all spectral behavior, whatever is shown here, it can be given further to the machine learning, and q factor has been calculated. So you see that, so for this value, for the value of this 1.36, 3.3000 is very good q factor is obtained. So this is for the, so you can see array of the blood cell in this region, then likely to be TB. So we have, we likely to be TB, and it is confirmed TB. And last is if array of blood cell is in this region, then likely to be TB is lowest. So these three further data we will give for the machine learning. So this is the Q factor calculated and the transmitted power peak and wavelength shift. Then this is for the machine learning. So here only people will be interested. So in machine learning, this particular paper is in very good journal. It's there in the Scopus journal. So application of machine learning for real time we have done. So what we have done in the lab, in our laboratory, real time evaluation of salinity of drinking water we have done using machine learning with the photonic sensor. So everybody know the Naive-Bayesian classifier. So Naive-Bayesian algorithm is a classification technique based on the Bayes theorem with an assumption of independent among predictor. So what they have done, C is the target and X is the attributes. So what we have done, we have actually, we have taken the our graph values we have given to the Naive-Bayesian, and you can see here, I'll show you. Stop sharing is coming. Yeah. So you see, so this will be our workflow. First light source, then photonic sensor design, then signal processing, and then Naive-Bayesian, and then Raspberry Pi. So we have taken Raspberry Pi to show the display. So you can see that this is the design parameters we have selected, and you see this is our sensing layer, which is nothing but photonic sensor, which we have designed for water potability. So TDS, a total dissolved solvent we have seen in the water, and then you can see that this is our result. You see, when we are changing the salinity of the water from 0.01% salinity to 30% salinity, so even 0.04% of salinity is able to detect. Our design sensor can able to detect 0.04% change in the salinity. That time when literature survey we got, in literature survey they are not able, they were able to, they were able to detect the 10% change in the salinity only, and that time our result was very better compared to that. So this was our finding that as per the literature, some number this paper is there where they are told that minimum 10% salinity only change in the salinity. I mean to say is able to detect, whereas our 0.04% 4% of even change in the means I mean to say if slightest change in the percentage salinity of the water can be detected by our design sensor. And this is the salinity versus refractive index. So you can see now smart analysis we are telling. When we are talking about smart analysis, it means machine learning will come into picture. So you see that we have taken 3 case study, 500 ppm saline water, 2000 ppm saline water and 35,000. So we have plotted the graph and you can see that there is a different shift in the peak. It means easily we can identify how much ppm of TDS is present in the water. And this is the workflow, and you see that. So enter, see this is a Raspberry Pi. Enter training data in USB. Enter test data in USB. So when we will give you see 2000 ppm we have given and higher salinity we are getting TDS observed. So this we have done by using the MATLAB, by using the Bayesian algorithm. So machine learning. So 1000 ppm also we are able to detect. Next we worked on the diabetic biosensor and by using the AdaBoost. So this is the conventional method of diabetic, which is all painful and non-invasive and invasive technique. Invasive means pin pricking, and non-invasive means just allowing light to pass through your finger. It will able to take. So what are the limitation we have pointed out here? So photonic crystal sensor will immediately, it will in fraction of second it will give the result. And we are using the this machine learning for the AdaBoost algorithm. So AdaBoost algorithm is for the constructing a strong classifier as linear combination. The classifier, so we are training the model, and where the person is not having the diabetic and normal person, and the blood affected by the blood sugar, we can easily able to train the this one with the prediction model. So you can see that this is the smart analysis for the blood. So you can see here in this particular graph, you can see X and Y are scatterer plotter with X as input of sensor. So input of sensor means photonic sensor, and Y as output of the AdaBoost algorithm. So input is our sensor output, which is coming from the optical sensor, which we have designed ring resonator structure, and and uh, and output will be AdaBoost. So the chances of gaining maximum sensitivity using AdaBoost is indicated by the value of the random sample, which have a tendency of inversely varying with the present state of the chance per second, which can be shown with this classifier accuracy equation, and sensitivity also has been done. And this is the photonic sensor design parameter, and you can see that light is allowed to pass. You can see through the line defect light is passing, and in this line defect we'll put one drop of very, because total size is in micrometer, you can imagine that such a less amount of blood is required. And these are the two graph plotted for the normal patient and for the diabetic patient. So we collected these two graph, and normal person who is not affected with the blood sugar is blue color, and diabetic is for the red color. And you can see that this is the AdaBoost output, where we are getting the very good accuracy, 95.2%. We have trained the model. So the output of photonic sensor system is compared with AdaBoost output, and matches gives the accuracy of 95%. So this is the very good result. So this is the smart analysis. You can see the training data, then test data, and then finally we have combined training data and test data, and AdaBoost algorithm has to run, load the test data. This is the steps how we are doing, and again analysis and miss hit for each weak learner. So we in this way we can able to detect and the conclusion. So these are the following structure we worked: biosensor and for lab on chip, for the naive Bayesian algorithm, and for the AdaBoost. So patent and all, not these are the references. Okay, thank you.
Thank you, ma'am. It was very informative.
Yes.
Your research
Any
is
question?
absolutely amazing.
Yeah, yeah, because time is short, so I finally fast I have gone. Mm,
I understand, ma'am. Your work is so good. You need a lot of time to explain.
yes. Yeah.
hopefully, we can have another session for this.
Okay. Thank you very much. So thank you for giving me opportunity.
Thank you, ma'am. Thank you so much. Neha?
Thank you, ma'am, for such an informative session. Session was really wonderful, and I invite participants. If you have any doubts or queries, please ask and please be quick. I request participants, if you have any doubt, please ask in chat box. Well, I guess no questions are coming, so I would like to call Engineer Aruna Devi, ma'am, for next session. Before that, I would like to give a brief about Engineer Aruna Devi. She is a chartered engineer with masters in computer applications, has more than 28 years of industrial experience as a successful entrepreneur and 10 years as an academician at University of Mysuru and Amrita University. She is proprietrix at Surabhi Softwares Mysuru, Software Development and Training Center and Authorized Training Center for Tally Education Private Limited. She is also managing partner at Premier Polymers, Mysuru, and National Nylon Fabrics, Mysuru. Well versed in the latest software tools, she is an IT corporate facilitator for senior officials of industries and postgraduate students. She is an external project guide and mentor for BE, MCA, MBA, and MTech students at various colleges. She is also a life member of IEI, CSI, ISTE, IEAE, etc. Survey, she has been also IP chairperson of CSI Mysore chapter and past CSI Karnataka state student coordinator. I would, and she has also been awarded with many awards like Successful Woman Industrialist, Best Woman Entrepreneur, uh, Best Woman Achiever, etc. We are very pleased to have you, ma'am, with us. I request you can please continue with your session.
Yeah, thank you, Neha, for the wonderful introduction. I think my presentation would be just at a very basic level because I had mostly targeted the student community. So I will quickly finish try to convey whatever I wanted to convey, and then shall I share my screen?
Yeah, sure, ma'am. No issues.
Yeah,
You can take as much time you want.
yeah,
Thank you, ma'am.
yeah. So with the history of artificial intelligence, so the wave started in 1950, the first time when it all started. And then in 1955, John McCarthy coined the word artificial intelligence. And in 1974 was the time when the computers, fast computing and computers became very affordable. And in 1980 was a year of artificial intelligence, and there onwards, from 2000 onwards, artificial intelligence has established and achieved a lot. So mainly, I will just highlight on the difference between AI, vs, machine learning and deep learning, because these are the three topics which are being discussed at large these days. So artificial intelligence originated around the 1950s, and then a decade later, machine learning had originated, and in 1970s, it was deep learning which originated. So now what is the difference between these three, is that thing. So AI represents stimulate intelligence in a machine. But machine learning is a practice of getting machines, to work, to make decisions without programming them. And deep learning is a process of using mainly neural networks to solve complex problems. So in a nutshell, AI is a subset of data science. So we know, all of us know how data is being generated these days. Every second, trillions bytes of data is being generated, and it is being stored on the cloud. So AI first started its step in solving out this data science, that is getting the data what was required. And then machine learning is nothing but it is a subset of AI and data science. That is, it is still a narrower gap. And then you have deep learning, which is a subset of both machine learning, AI, and data science. So now, what is the main aim of AI? So AI is to build machines which are capable of thinking like humans. Okay, so that is what artificial intelligence is trying to do. It's trying to build up robots and other machines so that they think like humans and act like humans. So, but the aim of machine learning is we give the input and you give the results and you get the program out of it. So aim is to machine learn through data so that they can solve problems. And in deep learning, what we are doing is we build neural networks automatically and discover patterns for feature detection. So feature detection is one of the major area of study these days. Like you have got in the medical field, wherein we are people, the doctors and they're trying to discover the cancerous cells at a very in the beginning stage, so that they can treat the patient at a very fast before it goes into the fourth stage of cancer. So this deep learning will help doctors and other medical professionals to treat patients and even to avoid blindness when there are things. So there are a lot of applications of AI, ML, and deep learning which are being taken into account. These artificial intelligence and machine learning are a part of computer science that all of us know, and they are correlated to each other. So these two technologies are the trending technologies which are creating intelligent systems. Intelligent systems in the sense we mean like, systems which are able to think. So these days, once you program a system or you give an input to a system, so depending on the type of application, these systems are able to give you the output. So that is what we mean by creating intelligent systems. So although these machine learning and AI are two related technologies, but they are different in certain ways. So now you can see the artificial intelligence and machine learning in this. So AI is a bigger concept to create intelligent machines that can stimulate human thinking capability and behavior. So what these robots are trying to do is they are trying to imitate the humans in their behavior. So that is what. Whereas in machine learning, what we do is we allow machines to learn from data without being programmed explicitly. So in machine learning, what we do is we feed the past data and then we try to get the output and try to get a algorithm or a program which will help us match the required output. So artificial intelligence in a nutshell is nothing but, it involves machine learning algorithms such as reinforcement learning, algorithm and deep learning neural networks. So AI is being used in multiple places, like the Siri that you have and the Google AlphaGo AI and the chess playing, etc. So artificial intelligence these days, all your smartphones, all that you're having, the Siri app, the automatic typing, and all these are being all everywhere. Artificial intelligence is being used, whether we are aware of it or not. So artificial intelligence is one of the most upcoming fields in the computer society. So basically, based on the capabilities, artificial intelligence can be classified into 3 types. That is a weak AI, general AI, and strong AI. So now what is it that we are using at the present? So currently we are working on with weak AI and general AI. The future of AI is strong AI, for which it is said that it will be intelligent than humans. So what you might be wondering, what is the difference between what is strong AI? So strong AI has a complex algorithm that helps in act in different situations, while all actions in weak AIs are pre-programmed by a human. So in weak AI, all the actions are pre-programmed by a human, but in strong AI, there would not be any programming. So AI-powered machines have a mind of their own. They can process and make independent decisions, while weak AI-based machines can only simulate human behavior. So in the future, from weak AI to general AI, strong AI would be the norm, wherein the machines, they would have their mind, they would have the capability of thinking on their own. So they would be, now what is the difference is, we say that the artificial intelligence, that's the robots, they do not have a thinking power, but in the future, when strong AI is implemented and we have stronger devices, more computational technology taking place, it would just so it would the humans would be replaced, because the machines would start thinking, and there would not be any human intervention anywhere. So now the difference, traditional programming versus machine learning approach. So in the traditional programming, we have the input as a data and the program. So the computation program is there and we get the results. But in machine learning, we have the data, we have the results, computation takes place, and we get the program or the algorithm. So this is the main difference between traditional programming and machine learning approach. So machine learning, okay, I'll just quickly go through this. What is it? Machine learning enables a computer system to make predictions. So that is more important, or take some decision using historical data, without being explicitly programmed. So machine learning uses a massive amount of structured and semi-structured data, so that a machine learning model can generate accurate result or give prediction based on that data. So that is what machine learning basically does. So what in machine learning we do is, we have the previous data, historical data, we feed the data and we feed the program, that the output that you want, and then it would give you the results. But what happens is, in machine learning works on algorithms which learn by its own based on your historical data. So it works only for specific domains, such as if we are creating a machine learning model to detect, say, pictures of some dogs or cats or whatever it is, it will give result for dog images only. But if we provide totally a different data set, like the images of a cat, then what happens is it will become unresponsive. So machine learning is being used in various places, such as for online recommender system, for Google search algorithms, email spam filter, Facebook auto friend tagging, suggestions, etc. So all of us do tagging in Facebook. So what is gone behind that system is the machine learning algorithms, or the machine learning that has been used in using tagging and in giving suggestions and other things. So machine learning is basically divided into three types. We have the supervised learning, the unsupervised learning, and the reinforcement learning. So what do you mean by supervised learning? So in the supervised learning, the system tries to learn from the previous examples that are given. So on the other hand, in unsupervised learning, the system attempts to find the patterns directly from the example given. So in the supervised learning, you can just think of the classes where there is a lecturer or a faculty and they are supervising the students. So the students are learning directly from the faculty or from their teacher or the who is present in the class, and the students are being supervised. But in unsupervised learning, you can think of the online classes which are being conducted these days, wherein there is nobody to supervise you. Okay, it is from your experience, it is that you are trying to learn. So speaking mathematically, supervised learning is where you have both input variables and output variables, as I showed you in the previous slide. That is, you have the input, you have the result, and then you get an output as your program. So the mapping function, that is, you have the input variable as X and the output variable as Y, and you get the algorithm. So the mapping function is expressed as Y, that is, the output variable is a function of X. Okay, so now this is what supervised learning does. So you supervise the learning process, meaning the data that you have collected here is labeled. So in structured thing, in supervised learning, we have the labeled data. In unsupervised learning, we do not have the data labeled. So you know what input needs to be mapped to. So here you can see you have got an apple and then you're trying to map it with banana. So the result would be no. So in the other image that you see here, you can see that you are having an apple and you are trying to match that with an apple. So the output would be yes. So this helps you to correct your algorithm if it makes mistakes in giving you the answer. So that is what supervised learning does. So that is, if you take the example as I gave you in a classroom. So if there is a faculty or a lecturer present, so if the students are being monitored or supervised, so if they are making some mistakes directly, they can be corrected. But in an unsupervised learning, what happens is only by experience that is being learned. So if they are making some mistakes, then they cannot be easily corrected. It is only from the learning and repeatedly carrying out the algorithms that they correct themselves. You get the correct results. So categorization of supervised learning. So supervised learning problems can be further classified into two, that is the classification and regression. So in classification, what we do? A classification problem is when the output variable is a category or a group. Like you have got some black or white, spam or no spam. So you can classify your data into categories, that is into groups. And regression means a regression problem is when the output variable is a real value, like such as you have got the rupees, height, weight, age, and all those. So because these are all labeled data, okay, and these supervised learning makes use of structured data. So this is what is supervised learning. And in unsupervised learning, the algorithms are left to themselves to discover interesting structures in the data. So it is learning by experience or learning by making errors. So there is nobody to supervise you. This is called, mathematically unsupervised learning is when you have input data and no corresponding output variables. So that is, you do not know what your output is going to be. So you have to figure out what the output variable is going to be. So in the unsupervised learning, we just have the input data and there is no particular corresponding output variable. This is called unsupervised learning because unlike unsupervised learning above, there are no given correct answers and the machine itself has to find the answers. So this is like if you want to, you have got several images of different types and you want to, get the image of a particular character. Then what you do, it is by matching or mapping several times that you want to get your output. So the main difference between supervised and unsupervised learning. So the data set in the supervised learning is labeled. See, you saw that apple figure and it has been, but in the unsupervised learning, it is unlabeled. So this is a guided learning. Here the algorithm learns by itself using the data set. This is a simpler method, and computationally, this is a complex method. And supervised learning gives you better results, and this is a less accurate result. So now categories of unsupervised learning. So unsupervised learning problems can be further classified into association and clustering. See, all these association, clustering, regression, all these we use, in research methodology whenever you have to analyze your data. Okay, depending on the type of data you want, you check whether there is an association between the thing, or clustering, or grouping, or classification, and regression, and other things. So association means an association rule. Okay, problem is where you want to discover rules that describe large portions of your data, such as people that buy X and also tend to buy Y. So there is an association between people buying a particular product and people also buy another product. So that is what we try to find out, that association. For example, if you go to the to a store. So when you buy milk, then there is a possibility that you might buy curd also. So that is the association that we call. Then clustering means a clustering problems where you want to discover the inherent groupings in the data, such as grouping customers by purchasing behavior. So now when you see, especially when you carry out the behavior of humans, okay, purchase, so when you see a person buying some repeated things, or they're purchasing, that is, you group people into clusters, that is, people who have the same buying behavior. Say people buy electronics items, people who are crazy about electronics, so you have a cluster, or you can see they often buy. So that is what is done, but you do not know what the output is going to be. Say if you give mobile, and you will not know what the output, whether people would, all of them would buy that mobile or not. So that is what we mean by unsupervised learning. So reinforcement learning means a computer program will interact with a dynamic environment, changing environment, in which it must perform a particular goal, such as playing a game with an opponent or driving a car. So the program is provided feedback in terms of rewards and punishments as it navigates its problem space. So this is in reinforcement learning. What we do is, we know that we have to perform a specific decision has to be taken. And when you are playing, you know that you have to play against an opponent which trains itself, and by a trial and error method, you will perform your task. So now, how is AI different from natural intelligence? So AI, as we have seen, is non-creative. But when we go into the strong AI, you know that it will machines will have the mind of their own. So they would become creative when the technology further advances. And artificial intelligence are precise, but natural intelligence, you can commit errors. Then these results are consistent, but we humans are non-consistent. And machines can be multitasking, but we can't handle more than 2 or 3 tasks at a time. So that is why most of the people, are going in for robots and other things to perform their tasks. Yeah, so I'll just skip this slide. So only thing here is AI has a wider range of scope, whereas machine learning has a limited scope. That we know, because machine learning is a subset of artificial intelligence and data. Okay, now I will just quickly cover up few applications of artificial intelligence and machine learning. They're almost the same, but there are some different ones. So applications of AI, nowadays artificial intelligence or computers are being used in every field. You take the banking and finance, you take the healthcare, you take the retail, you take the manufacturing, you take the e-commerce, you take the telecom, you take the marketing and sales, you take the education, you take the travel and logistics. So everywhere, without our knowledge, we are using artificial intelligence in one way or the other way. So so if you take AI in commuting, so what do you mean AI in commuting? See, these days, what happens is the to commute has become, the time that is being taken to commute from one place to another, it is increasing, and that is reducing the productivity of an individual. So what the companies have come, all of us have heard of ride share and apps like Uber, Ola, Lyft. So how are these companies able to match, the price that they should be charging, or how are they going to, passengers minimum detours and other things? So it is artificial intelligence which works behind the scene. So it is only because of artificial intelligence and the cloud that these companies, they are able to reduce the travel time of the passenger to a very small, because see, you are located in one place and tomorrow you want to hire a cab. So how do you know which cab is very close to you? So it all works on artificial intelligence. And then smart cars and drones. So years ago, smart cars or driverless car that we call, were a dream. But now we have got all automatic cars, wherein you just switch on the thing, and even without changing your gears and other things, you are able to travel. And even driverless cars have come, so that, just you feed in your data where you want to travel to, and with further no other input, you can just reach the destination. So, and these cars, they're trying to avoid, kinds of a number of accidents are going to be reduced in the future. And so smart cars and drones, as previously discussed, they are helping, especially in the medical field, wherein, the organs of a patient has to be transported from one location to another. So these drone systems have, become a very boon to most of them, to save even lives. Drones are helping to save lives, because suppose a death takes place somewhere, and that organ has to be, lifted from one place and be implanted in another person's, say, heart or kidney or other things. So drones have become lifesavers, and these all work on artificial intelligence. And your smartphones, as you know, all the apps that you have on your smartphones are all controlled by AI. Then media streaming services like the Netflix and other things. So whenever you are doing streaming, they will give you suggestions that you can even watch something else which you are interested in. And banking and finance. Yes, all banks these days, after the core banking system, they have adopted the artificial intelligence, wherein they are able to, reduce the number of frauds that are taking place. And then they are able to, help make better investments. And then you are able to check the mobile deposit and the credit decisions and customer services and many more. Applications are being provided by the banks and finance agencies. And whenever you make a transactions in the bank, immediately you get a message that a transaction has been taken place from your account. So this helps you, to check whether it is you who have made a transaction or not. And then what happens is, with this help, you can keep track of your balances, and frauds can be avoided. So, and navigation and travel. See, most of us are using, Google Maps to means find location. So earlier, if you had to go to a unknown place, it was very difficult, and you would ask people the route or the location of the place. But now, the moment you step into your vehicle and you put on the location destination, then the Google Map automatically takes you to the destination. So this is one of the most important, application of AI. Then video games. Yes, nowadays almost real video games, all are being, they have been developed, which, really are very attractive. And sometimes they, that blue whale, which was, developed, that was an addiction. And it was really very, very dangerous also, because people, who got addicted to it could go up to any level. Yeah. Then you have the smart keyboards applications. So nowadays, when you start typing something, so it automatically gives you suggestions for your words, and it corrects the spellings and other things. So that is also an application of AI. Then smart speakers. Yes, you have got all the speakers and other things which give you the, once you start conversation, it continues, sometimes continues further. Then online ads network. Yes, this is one of the most important, wherein companies are making money. So with the online ads, it is able to check, know the behavior of the person. Say suppose once you have accessed a particular ad on your system, the next time it gives you suggestions with similar type of projects that products that you may be interested in. Then social media feeds. So most of us, use also social medias like what you call Twitter, Facebook, LinkedIn, and other things. So that will help you. Uh, uh, this is also again because of what you call AI. So your choices and decisions are making just because of AI impact. So for social media feeds that you're watching on the timeline, for the alerts and notifications, so you get an alert in your WhatsApp message, or you get an alert in your Facebook or in your Twitter and other things. So these are all because of the applications that is curated by artificial intelligence. So AI software will analyze your previous interactions, web searches, and will behavior, and it will give you suggestions that the data and post and your suitable interest to the best. Then next is your smart home devices. Yes, on at least many of the homes, they have turned smart. Like what happens is now people are using this automatic dimming lights and automatic temperature control systems. So that depending on the number of people also, and the number of uh, uh, I mean the temperature outside, inside, so it automatically maintains the temperature of your home. And even the especially the where it is being used is your lights that are being used in various showrooms and other things. So they have got sensors which sense the presence of some kind of an obstacle or a person is there, then it automatically switches on. And then once a path is clear, then the lights automatically dim. And depending on the day and night mode also, your lighting also automatically changes. So these are the two main applications which are being used in homes. And even in some of the homes, they are using automatic door lock systems, and recognizing the face, so that only people who are in members of that house can directly enter into the homes. So all these are some of the applications of AI that are being used. And then smart email apps. So what happens is now you have gotten, so it bifurcates your email into spam, into bulk, and into your inbox. So all that, how does your account know that which email has to go into spam and which email has to go into your regular inbox? So it is AI that is working behind it. Then security and surveillance. So every these days security is the biggest challenge for any industry, any home. So what happens is these days, like security devices, just a second please. So like there are so many security appliances which are being used everywhere, and there is surveillance. So in police stations and in big uh, malls and other things, you have got cameras which are placed in various locations. But it is not, they're not monitored by by a single by various monitors, but the whole thing is captured at one location. So this helps in a lot of security issues which are taking place. And cyber these days, lot of cyber frauds, cyber thefts, cyber crimes are taking place. So artificial intelligence is being deployed or used in managing or reducing these kinds of cyber frauds, cyber thefts, and cyber crimes. So now comes is the healthcare industry. So most of us know these days how the operations surgeries are being taking place. So robotic surgeries that are being taking place, and how the patient's data is being sent through the cloud to the respective doctors. So in the healthcare industry, it has become a boon. Sometimes the assistance of the doctor is not easily available. So by making use of this artificial intelligence technology or softwares, it is possible to save people's life, to a greater extent. And even sometimes it is possible to detect the disease at a very early stage, so that the patient can be saved. So in the case of cancer, and in the case of some problems with eyes and lungs and other things, so if it is detected in the beginning itself, so lives can be saved. And e-commerce, of course, we know what e-commerce is. Nothing but nowadays everybody is doing online shopping and other things by making use of various websites and other things. So this is again by the use of artificial intelligence only. So all these I have already covered. So I will just, so in heavy industries, so a huge machines involve risk in their manual maintenance and working. So now what is happening is they are using all automated AI agent in their operation. See, in heavy industries earlier, what used to happen is all those big cranes and lathes and other things were being operated manually. But that was again a risk to the humans. And so now what is happening is that with the help of AI, all these machines are automated and they are being controlled. And education, all of us know how artificial intelligence tools are being used to solve certain problems. So I will just come a little later on that part of it. Yeah, so some statistics that is related to artificial intelligence growth. So according to the report of markets, the AI market will grow to around $190 billion industry by 2025 at compound annual growth rate of 36.62%. So you can see how big the AI market is. So people who are working in the AI market, or who plan to work in the artificial intelligence market, or people who want to develop apps, especially the computer science students, you have got a very good future ahead of you. So take it seriously and try to develop something which is going to make a difference to the society at large. Then according to Gartner, 80% of emerging technologies will have an AI foundation by 2021. See, now, yes, nowadays, see, most of the devices that we are using, almost all the smartphones that are being used, all are having AI behind it. The automatic cars that we are using, okay, they are also means having AI. The various electronic machines that we are using at home or at our workplace, all these are AI enabled. So Gartner surveyed that 37% of organizations have implemented AI in some way or other forms, and which is a 270% increase in the last 4 years. So just 37% is 270% increase. So imagine in another few years, what would be the increase in the use of AI. Then IDC predicts that 75% of commercial enterprise applications will use AI by 2021. So this is because why are we using artificial intelligence, or why are we using robots and other things, is because it makes a life much easier, and they perform the task. The prediction rate is, the accuracy is very high, and the time taken is also very low. So that is why people are preferring, the use of machines for performing their job. So it is in another few years, it is predicted that human intervention would be nil in most of the places. So recent updates. So Microsoft wants to crack the cancer code using artificial intelligence. So that is what Microsoft is aiming at. That is, cancer is like a computer virus and can be solved by cracking the code, according to Microsoft. So what they mean is this, that like the as Preeta Shah has already discussed, like how, you know, by studying the various cell structure of the human and, you know, testing it, you know, and having proper things. So this particular the computer applications, you know, they can detect the cancer cells in the human body at a very early stage, and that can be prevented further. So researchers are using artificial intelligence in a new healthcare initiative to target cancerous cells and eliminate the diseases. Like how polio was totally eradicated from the world. Similarly, researchers are trying even to, you know, eradicate, at least to cut down the effect of the people who are affected by cancer, because it is just a kind of malfunction of certain cells that takes place. So once these cells are found out, or they are predicted, or their lesions are the location is found out in the human body, then it can be easily treated. So IBM is working on a program called Watson, all of us have heard on, oncology, which again analyzes patients' health info against research data. Then Google is working with UK's government, you know, to use artificial intelligence in detecting and preventing eye diseases and blindness. See, these days we know a lot of us people are suffering from eye diseases, and if they go think they are getting blind. So if that eye diseases is uh, known at a very early stage, and it can be prevented by using corrective methods. So all these companies, big companies, they're trying to, you know, use artificial intelligence to detect or to predict the occurrence of a disease at an early stage, and that is what is required. So now, just another 5-10 minutes, I'll just wind up. So ML applications. So, you know, automatic language translation. So what do you mean by automatic language translation? See, we see people, you know, they're not very much familiar with English, or they know only their local language. So if nowadays automatic translators are available, wherein whatever you say or whatever you write gets translated into your language. So that is done. Again, it is an application of machine learning. Then image recognition, as we have already seen, face recognition systems, or if you want to do, you know, some kind of a analysis, like, you know, brain tumor detection and other things. So all these find applications in machine learning. Speech recognition. So how you have got the Siri, that app on your mobile. So once you say call somebody or message somebody, you have the Alexa system. So how does Alexa know what it has to play? It is through speech recognition that it is able to perform its task. So traffic prediction, yes, this is one of the thing, you know, people, when you travel, you know, every day, and you want to see the traffic prediction. So you see, you put on a map, and then you can see how much time it is going to take for you to reach from your source to your destination. So it gives you the traffic condition on a particular route. So sometimes when certain routes would be congested, so people take alternative route to, you know, to their workplace, just to avoid traffic. So this machine learning application, there are some traffic prediction which can be used, you know, to avoid people from the traffic. Then product recommendations. Yes, you know, once you have purchased a particular product, so your data would be captured. So when next time that you want to buy a similar kind of a product, then the recommendations would be coming up to you. Then self-driving cars, already they are not in India probably, but in foreign countries, there are self-driving cars, you know, as I told you, which that is again, you have got predictions. Their prediction is to be done from the source to the destination. So there would be a route which would be predicted, and the car would drive on its own and then stop at your destination. Email spam and malware filtering. So this is another application of machine learning, wherein your spam emails can be filtered, and your malware filtering. So the big companies, they have got firewalls installed in their servers, so that no mails from the unauthorized mail from their employees go outside their company. So this is one kind of a protection to keep track of the mails and other things that are being sent. Then virtual personal assistant. There are a lot of these things that we have got. This can be taken into this one. So you have got Siri, Alexa, Google, and all these people. So they act as virtual assistants for you. No, you need not physically dial the number or call somebody. So you use that particular app and tell Siri, you call somebody, or Siri send a message to somebody, or Alexa play a song for me. So all these are done by virtual. All these applications that we are discussing here have got machine learning algorithms or machine learning data, machine learning technology, which have been implemented. Online fraud detection. So these days, a lot of frauds are taking place online, especially when your credit card data being stolen or your passwords being stolen. So how do you detect that? So there are various softwares and various technologies which will detect the frauds that has taken place and give a solution. Then stock market trading. Yes, nowadays all the stock markets trading is done through machine learning algorithm, because the stock value, it changes every moment. So machine learning's long and memory, they use neural networks for buying and selling of stocks. So what happens is, the stock market these days, they're using high frequency trading algorithms are being used. So that is helping people make sell and make purchase of various stocks in the market of various companies, so that they make a profit out of it. So medical diagnosis already we have discussed. So these, we can say that artificial intelligence and machine learning algorithm are being used in every field these days. The technology is growing so much. Without these two things, that is artificial intelligence, machine learning, and deep learning. So deep learning means you have got various layers, as the word indicates, deep. So deep, you go deeper into the structure of the neural networks we call, and then you find out a solution. So these are the main applications of machine learning. So to the students, I don't know who are the people who are attending this particular webinar. So it is mainly targeted for the students, that this part of the slide. So if you are going to use machine learning, earlier we used to use MATLAB, and which was used for all your feature detection and mainly to deal with images. But Python, if you are learning Python, then you can perform all your machine learning, deep learning, predictions, selections, all those things, image detection, and all that can be done using Python. So to understand machine learning, hint to the students is, you first acquire a basic knowledge of Python programming. And in addition to that, what we have is, there are a number of library and packages generally used in performing various machine learning tasks, and their NumPy is mainly for your n-dimensional array objects. That, see, if you use other programming languages to deal with more than two-dimensional arrays, it is very difficult. But by using the NumPy package or library of Python, you can handle n-dimensional array objects. Then Pandas is a data analysis library that includes data frames. Then you have the matplot, which is a 2D plotting library for creating graphs and plots. Then skitlearn, the algorithm used for data analysis and data mining tasks. And Seaborn, a data visualization library based on matplot. So for the students, what you can do is, you can, I don't know how many of you can download Anaconda and start using the Jupyter Pi or PyCharm or so many other features of Python, which will help you to, write programs, or easily you just give some data and write some small lines of codes, because it's got all inbuilt functions. Prediction algorithms can be written and other things. So given you can predict the value, I mean what the weather is going to be tomorrow, or what the gold price is going to be, value of gold is going to be tomorrow, based on your previous data that you have got. So mainly all this, and you can do text summarizations, like many of them are working on text summarization of data, like Twitter data, Facebook data, and then you can create a word cloud. There are various ways in which you can use Python for your various projects and for learning and for creating various machine learning algorithm solving various problems. So now this one I will just quickly skip. I think it's not required. Yeah. So last slide I will just, okay, 1 second. Yeah. So till now the ultimate goal for the institutions and scientists working on an AI is to solve majority of the problems, or to achieve the task which we humans directly can't accomplish. So that is the main thing of the machines that we are having. So it is for sure that development in this field of computer science will change the complete scenario of the world. Not now, it is the responsibility of creamy layer of engineers to develop this field. So this is a nice opportunity for the students who are studying at Sri Shankaracharya Institute to take this opportunity to learn the technology and explore this particular field of computer science, wherein you can make a career into it. So the means like lot of jobs or lot of developments are going to take place in this particular field of science. So it can be connected to all the fields. So you can, your faculty, if you have got any doubts or any kind of a thing, you can approach your faculty, take their help, or other researchers or other people from the industry or other things, study what is the requirement, and then take up that as your career. Yeah, the last one, there is a magic, no more like gardening. So the seeds are your algorithm, nutrients are your data, and gardener, it is you, and the plants are your programs. So with this, I will stop my presentation because of the lack of time. I think I went very fast, but my thing was very basic, because I didn't want to share the work that we are doing, because it is sometimes illegal to share the work that we are presently continuing. So we are working on various projects like text summarization using various techniques, and like health informatics using deep learning, and then detection of brain tumors using ML, and all these are the things that we are working on. Earlier we used to make use of MATLAB, but now we have switched over to Python. One thing is because Python is open source and it is easily available, and it is easy to learn. And so with this, I give a suggestion to the students that if you are interested, master yourself in the basics of Python, make a career in machine learning or deep learning, and then you can go ahead in your future. Yeah.
Thank you, ma'am. Thank you so much for such a informative and wonderful session. It was really explanatory. I would like participants, if you have any doubts or queries, please ask quickly.
By the time the students are writing the questions,
Yes, sir.
it was very simply put, but very nicely explained.
No, my target.
Sure, the students have loved your.
Yeah, my target was mainly the students, because we thought what research we have already done, it would be too much for them, because That is what I had concentrated on the very basic.
Understandable, ma'am, but it was very nicely put.
Yeah.
Thank you so
Ma'am,
much for giving
Yes.
us the opportunity
someone has
to
asked question, implementation about strong AI, or has the implementation of strong AI started?
Not yet, because as of now we are working on weak AI and general AI. Strong AI means they are machines which would have a mind of their own. So 100%, machines are not yet designed in such a way so that they can, without any kind of intervention of the human or other thing work. So they have to be fed with some kind of a data, or some kind of input has to be given. And yes, so but in the future, probably it would take place, wherein everything would be, machines would be designed for, at least for certain applications, wherein they would be able to work totally like humans, wherein machines would take their own decisions and uh, work.
Okay, thank you, ma'am. I hope, Prasanna, your doubt is solved. Ma'am, another question is there. What is the use of augment AI?
Augment AI is now, like we are implementing, uh, you have got this, what you call that robot is there, no? That particular robot which, imitates you, like in anything that you do. So once it learns from your behavior, then you can use that particular robot or that particular machine to in your applications or something, so that further it will get programmed, or it will get take the data input. So next time if a similar situation occurs, then it would not require anything further inputs. It will do the task for you.
Okay, thank you, ma'am. Another question we have is, Sophia humanoid is strong AI or weak AI?
That is not a strong AI as yet, because that also needs some kind of inputs and other things. No? So if anything else different is given to it, it will not be able to perform. I think, I'm not very sure of it, but because Sophia, that thing, it has got its own limitations as of now. So that is the thing. If it is asked, that's what any other, see, like it repeats certain tasks over and over again. It has been programmed, say, for 10 or 15 or 20 tasks. So, but if it is given something different, I think, I'm not very sure about it. So it might not be able to, perform.
Okay, thank you, ma'am. Thank you so much. I guess we are done with the question and answers.
Yeah.
Thank you. I once again thank you for such a wonderful presentation and session. Now we can conclude the session. So for concluding, I would like to call Professor Srijit Panikkar, co-convener of this webinar, to extend vote of thanks.
Thank you, Neha. It's given me immense pleasure to convey my thanks to Professor A.K. Nayak, Mr. R.K. Vyas, Mr. Mukesh Kumar, Dr. P. Kumar, Dr. Brojo Kishore Mishra, and other CSI dignitaries for their presence. I express my gratitude on behalf of Sri Shankaracharya Engineering College to our distinguished speakers, Professor Dharm Singh Jat, Professor Preeta Sharan, and Professor Aruna Devi, for sparing your valuable time and sharing the technological advancements in IoT, AI, and ML. I would like to thank our chairman, Sir Shri I.P. Mishra, President Ma'am Jaya Mishra, Director Dr. P.B. Deshmukh, Principal Dr. Chinmay Chandrakar for their support and guidance. Special thanks to Professor Nayak, Sir, Mr. Mukesh Kumar, Dr. Brojo, Sir, for their support that made it possible for us to conduct this webinar. I thank Dr. Monica Srivastav, State Student Coordinator, for coordinating with the Computer Society of India and all faculty members of the CSE department for their active cooperation. Thank you, ma'am. Thank you all once again. Thanks a lot.
One request to the students, please fill in the feedback form for the e-certificates. Thank you. Thank you, ma'am.
Yes, ma'am.
Thank you.
We can end the meeting.
Thank you for being with us.